He knew what he saw wasn't natural. For months, he'd whispered the same line into the recorder. It's too stable, too deliberate. When the silence came from NASA, he understood. It wasn't only the signal that had gone quiet. It was him. When the faint light of 3I Atlas first appeared in mid-2025, no one outside a handful of observatories even noticed. The Atlas survey in Hawaii marked it down as a slow-moving object with an unusual approach vector. Within days, orbital data confirmed the unthinkable. It wasn't bound to the sun. It was an interstellar visitor, the third ever detected, arriving from somewhere far beyond our system. Astronomers called it 3I Atlas. Inside mission rooms, someone quietly said, "We've been given another chance." The first visitor, Oumuamua, had slipped away before instruments could even react. The second, 2I Borisov, behaved like an ordinary comet. But this one was different. Bigger, heavier, and strangely exact in its movement. The man at the center of this story was a mission data specialist. Let's call him Dr. Elias Reed. He'd spent 2 decades decoding noise, parsing the faint signatures of distant rocks, correcting for instrument drift, chasing meaning through error bars. He didn't chase headlines, he chased clean data. When 3I Atlas appeared, he was quietly assigned to track its light curve and orbital anomalies for the Deep Space Monitoring Program. At first, nothing seemed off, but as the days turned into weeks, he began noticing a pattern in the noise, a subtle rhythm that refused to smooth away. The object brightened exactly as predicted, yet its motion refused to match standard Comet models. The jets of gas that should have pushed it off course weren't doing so. Instead, it stayed locked on a trajectory that looked too perfect. He began a private log. "We're used to chaos," he recorded, his voice calm and clinical. "But this one subtracts chaos. Every time I think I've found the messy part, the numbers come back clean." By late September, astronomers at Harvard, Avi Loeb among them, announced that the object's non-gravitational acceleration was far weaker than it should be. If 3I Atlas were shedding gas, it ought to twitch and wobble. Instead, it cruised forward like a guided probe. Calculations suggested a nucleus 5 kilometers across, 33 billion tons of rock and ice, 3 to 5 orders of magnitude heavier than any known interstellar object. It was an outlier so extreme that statistical models simply broke. To most scientists, it was a fascinating puzzle. To Reed, it was the start of a long, sleepless countdown. The agency wanted coordinated coverage when 3I Atlas approached Mars in early October. 2 European orbiters, Mars Express and the ExoMars Trace gas orbiter, were in position to observe the encounter. Neither was designed for this kind of work, but both could capture faint light in multiple wavelengths. Reed's team was tasked with synchronizing data windows between the European craft and NASA's deep space relays. On October 3rd, the first images arrived. Through the haze, a delicate coma glowed against the black. The nucleus itself was invisible, buried beneath a mist of vaporized dust. Yet something about the pattern was wrong. The coma's brightness dipped and flared in regular intervals, like a heartbeat. Reed checked the telemetry, recalibrated, and ran it again. Same result, a rhythmic modulation, repeating every 9 hours. He wrote a note in the margin of the log. If it's rotation, it's precise to the second. On the surface of Mars, Perseverance was scanning the sky for calibration images when its navigation camera caught a long, thin streak cutting through the darkness above Jezero crater. Each exposure lasted only a fraction of a second, but stacked together, the streak appeared almost 50,000 kilometers long, far too large to be real. When the composite reached Reed's console, he stared at it for nearly an hour before labeling it what it likely was: motion blur. A trick of long exposures, a product of the rover's fixed lens. Still, he kept the image on his second monitor, replaying the data like a heartbeat that wouldn't stop echoing. That same week, as 3I Atlas swung past Mars, a coronal mass ejection from the sun lashed the object with charged particles. If it were fragile, it should have fragmented. But the coma held firm. No break-off, no plume, no debris cloud, just a slow expansion, as if the object had absorbed the impact. Reed wrote, "It behaves like a sealed system." Then the blackout hit. A government shutdown paused NASA's public data feeds. Telemetry continued privately, but the flow of updates to the public dashboards stopped mid-sentence. To the world, it looked as though the agency had gone dark at the very moment an interstellar object brushed past another planet. To Reed, inside the loop, it meant he was suddenly alone with data he couldn't share. He kept working. Night after night, he logged into the restricted server watching the Comet's subtle heartbeat flicker across new frames. It wasn't bright enough to demand attention, but it was persistent enough to haunt him. Each pulse corresponded to a slight shift in spectral signature, nickel appearing where iron should, then fading. He considered instrument error, solar interference, cosmic rays. None fit. If the signal is real, he dictated softly, then the composition changes in phase with rotation. That implies structure, something beneath the Comet controlling release. By the time the public realized NASA's feeds were quiet, conspiracy threads had already begun spinning. Talk show hosts speculated about alien probes. Online forums demanded answers. Inside the agency, there was only exhaustion and silence. Data analysis continued, but release schedules froze. Reed received an internal memo marked advisory only. Delay commentary until correlation confirmed. He understood what that meant. Wait until the noise settles, and maybe the story disappears on its own. He turned off the office lights and spoke into the recorder again. They'll call it a glitch. They always do, but if the periodicity holds through the next pass, we're not looking at noise. We're looking at a system. Outside, the world kept moving. Astronomers at the European Space Agency released blurred frames showing a faint pinkish haze near Mars's limb. To the public, it looked poetic. Another comet, another headline. But those who read between the lines noticed the absence of a tail. Comets announced themselves with flamboyant plumes stretching millions of kilometers. 3I Atlas wore only a subtle halo as if restraining its own exhale. For Reed, that restraint was the loudest sound he'd ever heard. He began cross-referencing the object's spin phase with solar wind data. When gusts intensified, the heartbeat flattened as if the object responded to the external environment, dampening its own emissions. He whispered to himself, "Adaptive behavior." Then he crossed the phrase out of his notebook. Colleagues described him later as precise, methodical, but more withdrawn during those weeks. He stopped joining morning briefings and spent long hours replaying light curve animations. One coworker recalled walking into the lab and hearing him murmur, "It's steering through the storm." When asked what he meant, he smiled, minimized the window, and said, "Just running stress models." That night, he updated his private log. The outgassing vectors oppose solar flux. Minimal, but measurable. If this is coincidence, it's exquisite. When Avi Loeb's Harvard group published their preliminary findings, citing the object's anomalous stability and improbable size, Reed felt a small vindication. For a moment, the story wasn't just his burden. Then Loeb went further, suggesting the possibility of a technological origin. It was speculation, not assertion, but enough to ignite another wave of attention. Reed knew the agency would clamp down harder now. Speculation is a contagion in science. Once spoken, it spreads faster than data can disinfect it. He saved Loeb's paper, highlighted one sentence: "The object's mass and trajectory remain inconsistent with natural expectations," and pinned it above his desk. The blackout stretched on. Officially, it was a bureaucratic delay. Unofficially, it felt deliberate, an empty silence between questions and answers. Reed tried to file progress summaries through internal channels, but messages bounced back with polite placeholders. Pending verification. He wasn't being ignored. He was being contained. Night after night, he came back to his console, headphones pressed tight, listening to raw telemetry, as if data itself could speak. The rhythm was still there, faint, precise, steady. He began to suspect the pulse wasn't just rotational. It was modulated. He overlaid the sequence against radio emissions from solar wind fluctuations, searching for correlation. The peaks aligned, almost too neatly. It was as if 3I Atlas was mirroring the sun. He wrote one line he later deleted. Either the sun is teaching it to sing, or it's answering back. In early November, the object disappeared behind the sun. For 6 long weeks, it became invisible. No telescope could pierce the glare. All that remained were predictions. It would swing around the far side, reach perihelion at roughly 1.36 astronomical units, and then fade into outbound silence. But in Reid's notes, the anticipation turned to unease. He didn't trust the projections anymore. He had run the integrations himself. The orbit wasn't drifting the way it should. Something, tiny but measurable, was nudging it back on course whenever it strayed. Like correction burns on a spacecraft. He stared at the residuals on his screen. Every course correction was within statistical error. But together, they told a story. An object fighting to stay exactly where it meant to be. He recorded softly, "If these deviations persist beyond perihelion, the model of passive outgassing no longer fits. Something is maintaining trajectory." Then, after a long pause, "Something intelligent, or something designed to appear intelligent." December 19th, 2025. Earth distance check. 3I Atlas cleared the sun and re-emerged faintly in the morning sky. Observatories scrambled to reacquire it. The first spectra arrived smudged, full of interference. Yet beneath the noise lay a strange consistency. Nickel lines without iron again. It wasn't random chemistry. It looked intentional. Reid compared the ratios to known meteor samples. Nothing matched. He sent a quiet note to a contact at Harvard. "Check the nickel emission at lambda 2320 angstroms, repeating signature. It's not natural dispersion." No reply. Hours later, his clearance to the shared data server was revoked for security maintenance. He wasn't surprised. He'd been too direct. Instead of stopping, he copied the local backups to an encrypted drive and continued working from home. He didn't sleep much that week. The object's motion had slowed slightly, as if dragging a heavy field behind it. He began plotting resonance lines between 3I Atlas and nearby planets. The numbers hinted at harmonics, a faint dance of gravitational sympathy, as though the visitor adjusted itself to avoid deeper perturbation. He muttered to himself, "It's navigating through resonance gaps." Nobody answered. January 2026. The holiday lull ended, but public updates did not resume. Officially, NASA cited data integrity reviews following the shutdown. Unofficially, leaks whispered that several analysis groups had been told to pause speculation. The phrase circulated internally until it lost all meaning. Pause speculation. As if curiosity were a switch you could turn off, Reid wrote one last unsent report. It was thorough, technical, devoid of emotion. He concluded with a single paragraph. "If the object's density and outflow remain constant while maintaining orbital stability beyond predicted parameters, then either our model of mass-to-surface interaction is incomplete or we are observing active stabilization. Either outcome demands attention." He hit Save Draft and closed the file. When Jupiter's telemetry window opened in March 2026, 3I Atlas skimmed 33 million miles above the gas giant's clouds. The Juno spacecraft was repositioned for a brief sensor sweep. The data that came back looked ordinary at first glance. Faint dust, low-energy plasma, nothing dramatic. But within the magnetometer readout was a pulse periodic, symmetrical, and phase-locked to the object's rotation period. A magnetic heartbeat. Reid called an old colleague on a secure line. "You're seeing it too, right?" There was a long silence on the other end. Then a whisper. "We're not supposed to talk about it." The line went dead. For the first time, Reid allowed himself to feel fear. Not because of danger, but because of recognition. Everything about 3I Atlas felt engineered its resilience, its silence, its timing. And yet, no sign of hostility. No signal beamed toward us. No trace of purpose. Just presence. A passing observer. Maybe a relic. Maybe a seed. Maybe nothing at all. He opened his recorder one final time. His voice was calm, but slower now. Each word deliberate. "If anyone ever hears this, understand that I am not claiming knowledge. I'm describing behavior. We've always imagined contact as noise, a broadcast, a message. But what if intelligence can pass through silently, leaving only its shadow in our equations? What if 3I Atlas is not a visitor, but a reminder of how little we notice?" He paused, exhaled, and added, "If it is natural, then nature is more deliberate than we ever imagined. If it isn't, then we've already been seen." He stopped the recording. The file saved automatically, at 2:14 a.m. UTC. It would be the last entry in his log. 2 days later, he failed to appear for his morning briefing. Co-workers assumed exhaustion. His workload had been brutal. Security found his badge in the lab, his workstation still running the screen filled with a looping animation of 3I Atlas fading into the outer dark. No foul play, no trail, just absence. The agency issued a brief statement. Dr. Elias Reed has taken leave to address personal matters. The story ended there, but fragments of his encrypted notes surfaced months later among archived data releases, correlation tables, unexplained residuals, a final line of code tagged "Listen at Edge." No one could trace who uploaded them. Most assumed it was automatic cleanup from redundant backups. A few weren't so sure. Today, 3I Atlas is far beyond Jupiter's orbit, dimming with every day. To telescopes, it's a cold point of light, unremarkable, almost forgotten. But buried in the long datasets are anomalies that refuse to fade. The steady modulation in brightness, the non-gravitational symmetry, the chemical imbalance between nickel and iron, numbers that whisper of intention without ever confessing it. Official papers describe them as instrumental artifacts. Unofficially, the files remain marked for review. Some say Reed's last models predicted the object would eventually decelerate slightly, just enough to linger at the heliopause before drifting outward again. A pause at the boundary between sunlight and interstellar night. As if looking back, what terrified him wasn't invasion or secrecy, it was timing. 3 interstellar objects in less than a decade after billions of silent years. The odds are infinitesimal unless the void itself has grown busy. Unless someone, somewhere, has begun sending things again. He once wrote in a margin, "We keep arriving late to every cosmic conversation. Maybe 3I Atlas wasn't the first message. Maybe it was the first we noticed." In the end, the lesson isn't about conspiracy or cover-up. It's about perception. Science asks the universe questions. Sometimes, the universe answers in riddles. 3I Atlas could still be a frozen comet, an ancient shard ejected from a dying star. Or it could be something rarer, an artifact of attention. Proof that somewhere out there, curiosity is not unique to us. The data will remain, archived in silent directories. The orbit will be plotted, the light curves preserved, the pulse forgotten by most. But a few will remember. The faint heartbeat that matched the sun, the scientist who wouldn't stop listening, and the warning he left behind. Next time, we should be ready before the light appears. Next time, we should turn toward the edge and wait. When the data silence lifted, what returned was incomplete. The public repositories came back online with new timestamps, but gaps remained. Key telemetry lines from the days surrounding perihelion had been redacted, replaced with placeholders. Data under review. At first, it seemed procedural. NASA often withholds unverified datasets until calibration is complete. But this time, the missing frames weren't just calibration. They were the moments when 3I Atlas was closest to the sun, the exact window when its brightness should have spiked and its spectrum revealed its true composition. Independent teams tried to reconstruct the missing interval using ground-based data. That's when the anomalies surfaced. Across multiple observatories from Chile's Paranal to India's Hanley, magnetometers recorded subtle, synchronous fluctuations. Not strong enough to disrupt instruments, but identical in phase across sites half a planet apart. The readings matched the hours when 3I Atlas would have been behind the sun, invisible to direct observation. The coincidence was impossible to ignore. Solar flares could cause magnetic ripples, but no such flare was recorded. Space weather satellites showed quiet conditions. Something else, unseen, had brushed the electromagnetic field of our world. Faint, transient, but coherent. When these reports circulated through internal networks, the official explanation arrived quickly. Instrumental crosstalk, timing desynchronization, statistical coincidence. Yet the pattern persisted through audits. The probability that every site glitched in the same rhythm was effectively zero. To the scientists who noticed, the event wasn't proof of anything, but it was a signature, a whisper in the noise that said something passed between. Weeks later, the European Space Agency released a compressed archive from the ExoMars Trace Gas Orbiter. Inside were high-contrast images captured during the object's approach to Mars, moments before the global blackout. Most appeared as expected: diffuse halo, faint tail, minimal variation. But one sequence stood out. In a series of 7 frames, the coma brightened and dimmed in a periodic rhythm, almost like a heartbeat. The pulses weren't artifacts. Their amplitude was consistent with a physical modulation of reflected light. When the signal was detrended and converted to time-domain data, a pattern emerged, an oscillation repeating every 11.6 seconds. No known comet exhibits such stable periodicity. Outgassing vents create chaotic flares, not metronomic flashes. Some proposed it was the rotation period, a slow spin of the nucleus revealing brighter and darker surfaces. But the light curve didn't fit rotational geometry. It fit modulation, as if energy were being emitted and absorbed in a controlled sequence. The hypothesis was quietly shelved. No one wanted to fuel headlines. Still, in the quiet of private research groups, the discussion continued. If the 11-second pulse was real, then either 3I Atlas was tumbling with perfect regularity, or it was doing something more deliberate. During the following months, internal NASA documentation surfaced through ordinary channels, budget reports, staffing memos, maintenance logs. Hidden in plain sight were subtle reassignments. Deep space tracking arrays that normally monitored planetary missions were redirected toward Object 3I 2025A. The Deep Space Network's Canberra station logged unusual continuous tracking time, far beyond what a fading interstellar object would justify. Engineers requested additional cooling capacity for receivers operating at high gain, implying they were listening for something faint, possibly narrow band. But no such signals were ever released. The scientific community moved on. Attention shifted to other missions. Yet within that silence, a small group of astrophysicists noticed something strange in the publicly available telemetry. The residuals in 3I Atlas's post-perihelion orbit didn't match the pre-encounter predictions. The object had not only survived its pass behind the Sun, it had changed course by a measurable fraction of a degree. The deviation was subtle, but undeniable. It wasn't gravity. It wasn't radiation pressure. It was as if the object had applied a correction, a precise, gentle thrust toward a new trajectory that would lead it deeper into the solar system before exiting. NASA's official statement called it an effect of asymmetric outgassing, but there was no evidence of jets, no increase in brightness, no signs of rotation that could produce such an impulse. It was motion without motive power, a steer without smoke. Months later, while the world had turned its attention to other stories, a graduate researcher at the University of Oslo stumbled upon something buried in Mars Reconnaissance Orbiter's raw telemetry. A brief radio frequency anomaly logged 2 days after the blackout ended. For just under 4 minutes, one of the orbiter's high-gain antennas received a narrow-band carrier wave at 8.42 gigahertz, the same band used for spacecraft telemetry, but the signal wasn't from Earth. Triangulation placed its apparent source somewhere beyond Mars's nightside horizon, precisely where 3I Atlas's path would have been during that window. The amplitude was faint, the data incomplete, but the spectral shape was unmistakably artificial, coherent, steady, modulated. The report never reached the press. It was absorbed into a larger dataset labeled anomalous carrier, likely reflection. But the coordinates aligned perfectly. If it wasn't a reflection, then the signal had come from the object itself. By early 2026, 3I Atlas had passed its closest approach to the Sun and was headed toward Jupiter. Its coma had collapsed into a thin shell, the jets extinguished, the nucleus nearly invisible. And yet, its energy signature refused to fade. Infrared readings from the James Webb Space Telescope showed residual warmth inconsistent with simple solar heating. Something within the body retained heat long after exposure, as if its interior trapped and released energy in cycles. This was the point when Dr. Avi Loeb returned to the discussion. In a paper that drew equal measures of praise and outrage, he proposed that 3I Atlas could be an example of what he called a gravitational sail, a massive object using internal mass distribution changes to steer through stellar systems without traditional propulsion. If true, it meant the object was not passive. It was navigating. NASA declined to comment. ESA dismissed the model as speculative. But behind the scenes, several deep space antennas continued tracking the object's faint microwave reflections, logging data under designations that would never appear in public archives. When 3I Atlas neared Jupiter in March 2026, the planet's immense gravity offered one last chance to study it closely. Every major observatory turned toward the event. What they saw was extraordinary. As the object entered Jupiter's magnetosphere, it brightened, not in visible light, but in radio. Instruments recorded bursts of emission near the planet's natural auroral frequencies, as if the object were resonating with Jupiter's magnetic field. Then, just as quickly, the bursts ceased. The light faded, and 3I Atlas began to change direction again, a slight vector adjustment that set it on a course not for deep interstellar space, but for a plane that would in 2 centuries cross the orbit of another star entirely. To the few who watched those numbers update in real time, it felt like the closing of a door. When the data finally stabilized, 3I Atlas was gone beyond the reach of optical telescopes, fading into the galactic background. Its legacy, however, remained. Thousands of hours of recordings, fragmented data sets, unanswered questions. Was it a natural body with physics we don't yet understand? Was it a derelict probe, silent and ancient, passing through the corridors of space like a message written in the grammar of motion? Or was it something else entirely? A seed, a carrier, a fossil from the construction of other worlds? We may never know, but the numbers are there, in servers, in notebooks, in forgotten calibration logs waiting for someone brave enough to see the pattern, without fear of what it implies. In the months following its departure, a strange thing happened. Instruments designed to look for new interstellar bodies began picking up faint echoes, spectral signatures that looked eerily similar to 3I Atlas, but weaker, smaller, farther. Perhaps they were debris. Perhaps they were others. One by one, observatories flagged the anomalies, filed the reports, and moved on. None were confirmed. None were denied. But among those who had watched 3I Atlas pass, the realization settled like gravity. The solar system is not empty. It is a crossroads. Objects come and go, bearing the fingerprints of distant stars and maybe, sometimes, the designs of distant minds. Years later, when new trainees sift through the archives, they will find the same missing frames, the same data gaps, the same line items marked under review. They'll wonder what was hidden and why. And somewhere beyond the orbit of Neptune, in the cold where sunlight is thin and time moves slow, a 5-kilometer mass drifts on, silent, steady, precise. It doesn't care about our curiosity. It doesn't care about our fear. It moves according to laws we may one day understand or instructions we never will. For now, it remains what it has always been, a visitor from beyond the stars, carrying with it the quiet proof that we are not alone in this vast exchange of worlds. And when the next faint light appears at the edge of our telescopes, we will remember this one, the object that taught us the difference between discovery and comprehension. Because 3I Atlas didn't just pass through our solar system, it passed through our certainty and left a question that will echo for centuries. When we look into the dark and see a light moving toward us, how do we know it isn't already watching back?